Hello everyone, welcome back to another tutorial video. So in this particular video, we are going to cover how to build chatbots with Python. So all those of you who are interested in NLP or want to know how to get started with NLP using Python, this is going to be a really good video for all those of you. Now, what are we going to cover today? So we'll be covering the entire process of building basic chatbots. There are basically three types of chatbots. Now, first one is the rule-based chatbots. Now, where we have a predefined set of responses based on what sort of message, what sort of query that the user input, and accordingly we map that particular query with a particular response. So we are simply doing some regular expressions, checking and finding out which is the best fit response based on the user message. Simple rules that we have to define, and accordingly that model or rule-based chatbot basically gives us that response, predefined responses. So we have to simply write all of these rules. Now the second type is the retrieval-based chatbots. So here we leverage statistical modeling, language models like TF, IDF, vectorization technique, tokenization, pre-processing, and then we also leverage, we also use cosine similarity. We find out, like, based on the kind of response or the user message that we have received in the chatbot, we find out based on the corpus of data that we have, we find out which text or which sentence is the best fit, is the most similar or the most appropriate response for that particular query or that message. So that's how we build a retrieval-based chatbots. It includes TF, IDF, vectorization, cosine similarity, and basically simple statistical modeling, topic modeling, and there's this text similarity that can help us build a retrieval-based bot. And the last is, again, a very advanced deep learning bots, self-learning. These leverage artificial intelligence, of course. So all of these models that we see, all of these chatbots that you have on your phones, like Google Assistant, Siri, text to speech, generative models, so generative chatbots. So where these are leveraging LSTM models, RNNs, neural networks I'm talking about, and then they also leverage, now we have GPT-3 that has come in. So they use all of these models to actually create their own responses based on the query that actually they have been trained on a very vast amount of data. So that's why they perform better in comparison with the basic ones, so retrieval-based or the rule-based chatbots. So that was all about it. So we're going to cover simply rule-based and retrieval-based in this particular video. Generative models are an advanced topic, and it's for a separate video. So without any further ado, let's get started. So let's first talk about the baseline libraries that we are going to use. We are going to first use the NLTK library. Now, to focus on our rule-based chatbot, we have got a few utility classes and functions that are available in the NLTK library. Now, NLTK basically stands for Natural Language Toolkit, and it is one of the leading Python libraries to work with textual data. Now, here we are going to import the NLTK library itself, and we're going to import the chat module, which has some utility classes and functions that are defined for us in order to build that chatbot, the rule-based chatbot that we are focusing on for the first part of this tutorial. This is going to be really quick. You'll see that how easy it is to build a chatbot. It's just about specifying a set of rules, and that's all. So let's quickly import NLTK. So this is import NLTK, and then I am going to import from nltk.chat. In the chat module, I have some utility classes. So from nltk.chat.util, import chat class, and there's reflection object, reflection dictionary. So we have imported these three things basically, NLTK library itself. So run the cell. Now here, let's just check like what have we imported first of all. So if I check, let's say if I print chat, all right. So you see the chat is basically a class that has got some utility, logic that has been implemented for us to build a chatbot right on the go. It contains some helpful function. All right. Now the next thing that we have is reflections. So let's check that out as well. What's reflections here? Or you can simply skip print as well. So simply do print, and this would beautify how you have your output in your Jupyter notebook. So yeah, so this is what we have in reflections. Is basically a dictionary. It contains the user input on the left, which is serving as the key of the dictionary, and then in the values we have the output from the bot. So it's input text and its corresponding output values, and we can examine the dictionary. You can look at all the options. You see I am is corresponding to you are, I was is with the you were. So this is basically optional, and you can create your own dictionary in the same format. It's just like kind of like rules that we have already implemented in the library. All right, so you can define your own if you want to. Now the next step is to create rules that will be used to train the chatbot, and the lines of code below, basically the ones that we're going to write now. So this would basically mean a set of rules. So what we'll do is the first element of the list is basically the user input. So we'll be creating a set of list of lists, and the first element would be the user input, and the second element is going to be the response from the bot itself. Now we'll be basically creating this list and storing them in set pairs. So let's just define those set pairs. So set pairs. So as I said, this is going to be a list of lists. So here the first pair, let's say my rule is going to be so this is going to be a raw string. The R prefix states that it's going to be a raw string. So let's say a person says my name is anything. Okay, so we can specify dot star. Star means like anything. You say my name is dash. So the response from the bot can be this. Hello, and I can say the first name of that person. Hello dash, and how are you today? All right. So this is just another example, like just one type of response. You can also define other things if you want to. So this is going to be the first pair. Similarly, we can define a few other rules. So let's say the second one is let's say hi, hello, hi, or you can say hey, or I can say basically the user can say hello. So yeah. So if let's say if the bot comes across this hi, hey, or hello, then the response would be basically you can either say hello, or you can say, let's say, hey there. All right. So these can be the two possible options for the bot to choose from. All right. Now, similarly, we can define other set of rules. So I have created these rules myself. So you can just, I'll just copy them and paste them here. All right, this is fine. So these are a few rules that we have defined. So what's your name? You can call me a chatbot, or we're going to, so this is going to be a very simple one. So I have defined like I am looking for online guides to learn data science. Can you suggest? So it's going to say coding ninjas is great as a great option. and so on and so forth. I've added a few more rules here. So let's quickly run this and see if we should not have any error running this. All right, so all of our set pairs are now defined. Now the next step is to basically define the chatbot using the function. So let's quickly create a starting chatbot function. It's going to be very simple, simply a print statement. So let's say, hi, I am a rule-based chatbot, and what can I help you with? All right, so this is going to be the starting statement, and that's all. We're going to call the chatbot function. So, hi, I'm a rule-based chatbot. What can I help you with? Now, in order to start the dialogue here, we're going to use the chat class that we have. So first we'll instantiate the chat class. So let's create an object. And in this class, what you need to specify is your rules. So your set pairs, the rules that we have defined above, and the reflections. That's all. And then you print chat, and you see that your object is now created. Now, how do we converse? We use the converse method of this object, chat.converse. That's all. And we're going to start it with, let's say, if, so using the boilerplate code, main. I'm using Jupyter Notebook. You can also run it and do it in because this provides you a lot more visual interface to work with. So I'm calling the chatbot function here to start off. This will start our conversation, and then chat.converse would take it from there. All right. So now I can simply type anything, and it will see if the response can be chosen from the rules that we have defined. So let's say I said hi, and so it said hello. Okay, I will say my name is let's say Harshit Tyagi. So hello Harshit Tyagi, how are you today? So it's just doing that. All right, and now okay, let's say I'm looking for a course. Let's say, what does it say then? It says now, because the rules are strictly defined, I need to copy this entirely, and let's say, and now it should be able to give me the, yeah. So you see, I'm looking for an online online guides and courses to learn data science. Can you suggest? So it said Coding Ninjas is a great option to learn data science. You can check their website. All right. So this is the response that we got from our rule-based chatbot. So now you see how easy it is to implement a chatbot. Now this is just getting started. This is the simplest chatbot that you could have built. All right, with just a set of rules. But now we have we are in the age where we are conversing with the bots like Alexa, Google Assistant, Siri. So these contain these are open-ended bots, open-ended domains, and these are generative bots which use deep neural networks, deep learning models to create those generative outputs and bot responses. So that's beyond the scope of this video, but we are going to go to the next step, which is the retrieval based chatbot, and let's talk about that. And here in order to quit, we have added a quit statement. As you can see, this quit you can type a quit statement to come out of. So it said bye, take care. Okay, yeah. So it chose the second option. Yeah, it was nice talking to you. See you soon. Yeah, so that's all. And yeah, I think so. Let's talk about the retrieval based chatbot now. So talking about retrieval-based chatbots, now these are used in closed domain scenarios. Like you would have a chatbot to help you have a better experience to buy a particular, on an e-commerce website, or chatbots installed at airports to help you have a good experience with booking a ticket or buying a shoe of a particular size at an e-commerce website. So these are all closed domain scenarios. There are a bunch of them, and they rely on a collection of predefined responses to a user query or a user message. So a retrieval-based bot basically completes three main tasks. Now, these three tasks are intent classification, entity recognition, and response selection. Now, when a user inputs a query, basically our job is, or the retrieval bot that you would implement, its job is to first figure out what's the intent of that particular message, of the demand, and which all entities are involved in that particular query. So we have intent classification, and then we have entity recognition. So there are a number of ways to determine which response is the best fit for a given particular user query. And one of the most important decisions that a chatbot, developer or an architect makes is like which similarity metric should we choose in order to find out the best fit response. So there are two main techniques for these, the statistical modeling that we do in the response selection process. So there's one is bag of words. So the bag of words model are commonly used to compute intent similarity, and it measures based on the word overlap, but it's not that good. The disadvantage, or you can say the drawback of bag of words, is that there can be many occurrences of a particular word without any context or without any value. You can say the word the, in, or is. These words appear so many times in a document, but this doesn't mean that it would make a particular response more similar or a better fit for the user message. So we have another model, which is basically another technique. So term frequency, inverse document frequency. So that is TF-IDF. Now, basically, TF-IDF is another common similarity metric which incorporates the relative frequency of terms across the collection of possible responses. So the sklearn package, as you can see here, we have imported the TF-IDF vectorizer. It provides this particular class that we instantiate, and we create an object that we can use to fit our TF-IDF model. So this is the model that we build, which will actually figure out the similarity between the data that we have provided it as with the user message that we'll get in the chatbot. So here again we have imported a few libraries that we're going to use. Again, the main library, which is NLTK. Then we have NumPy. We might not need NumPy here, but I have it as well. So we have string, and then we have random and BS4. So what for this retrieval based chatbot, again, we need to have a domain. So I said I took an example of cuisine. So if anyone wants to learn about a particular cuisine, so I've used this. I'm making this cuisine chatbot. It would help us learn more about cuisine. So I'll provide it a corpus of data, text that it'll use to figure out the intent and find out which all responses can be actually throw the user's way to answer his query. So now these are the libraries that we are using. So BS4, this is Beautiful Soup. So we'll be taking an article from Wikipedia on cuisine. So that will be our corpus which we'll use. Now you can keep adding more information, more text to the corpus to create your own corpus for response selection. But I am using just one article just for this example, but you can definitely build over it. So again, then we have request to query that particular URL where we'll capture the data from. So I'll just show you that in our data collection process. Then I'm using cosine similarity. So this is what we'll be using to match the vectors, find out which particular response is the best fit between the user query as well as the vectors that we would create from the TF-IDF models. So again, this is very simple. I'm using these WordNet corpus for my processing, textual processing that we'll do. So I'll just show you that. So make sure that you download these two corpora from NLTK. And once you have done that, now the next main step is, first of all, is to gather data. So again, I have picked up this Wikipedia article on cuisine. Request is the library that I'm using. It has this get method. If I provide the URL to this get method, it returns all the different sort of objects. So we can definitely look at what this R contains. So if we run this, you can see it has, so this 200 means that it has returned a successful response. So this is basically that the link is available and we have data over there. So that's just a success response. The code 200 tells us that. Just like 404 is for not found. Again, so let's look at, so I am basically all of the text that is available on this article's Wikipedia page, I am storing it in raw HTML. So this r.text, this contains different parameters, attributes. So I am storing this in the raw HTML variable. So let's run this. So my raw HTML is now with me. Next step that I need to do is I need to beautify it. So I need to figure out or capture all the paragraphs. So this text would, this HTML would have images and all of those different things that we don't need. So we need to clean the data. You can definitely keep looking at what's inside of this text. So you can keep running each of these variables. So you'll see there's a bunch of special characters and things that we don't need. This is the raw text. You can see there's a lot of HTML, classes, style, and all of those things. But we don't need that. So what we'll do is we'll clean that up. So we'll create a beautiful soup object. Now this is the library that helps us beautify our textual data that comes from the entire website, helps us query all the tags. So to capture all the textual data, we are simply targeting all the paragraphs available on the Wikipedia page. So again, here I have created a corpus HTML object, which is basically a beautiful soup object. Now in this beautiful soup object, I can find out which all paragraph tags are there. So I want to capture all those p tags, whatever is available in there. So this is my corpus paras. I have captured all the paragraphs here. Now the next step is corpus text. So I've just initialized it with an empty string. Now I want to concatenate all these paragraphs. So these would give me a list of paragraphs. Find all gives you a list of paragraphs. You can again keep running them side by side and it'll tell you like what all responses or what all paragraphs are available. So what we'll do is we'll keep iterating over each of these paragraphs or each of these p tags data. So this would have textual data. We'll iterate over it and we'll keep adding or concatenating it to this main corpus text to create our corpus. All right, so this plus equals parag.text means that I am retrieving all the data, all the textual data in the p tags to this corpus text string. So I would have this entire string. I am then converting it into lowercase. So there's no uppercase or lowercase scenario here. So we have converted the entire textual data into lowercase. So let's run that. Now, if you want to look at this corpus text, so this is our corpus text that we have got. There's a few \n means new line. So that's just a notation. We'll have to get rid of these and we'll see that in a bit. So citation needed, all of these. So this is our textual data in lowercase and all the paragraphs from the Wikipedia page captured in this string. All right. So the next step is to create, basically first get rid of all of these special characters and empty spaces. So here we are using regex or regular expressions. So
So this basically means that I want to remove all the numbers or these special characters. So these are for the special characters, and these are for any empty numbers or spaces. So what I'm doing is I am getting rid of all the empty spaces and the special character from my corpus text string. So let's run that as well. Now the next step is to convert all of this text into sentences and words, because only then we would be able to find out, convert these into vectors and figure out which all sentences, which all words are similar to the user query. So based on the word tokens, we'll be able to figure out or calculate, pass these tokens to the TF-IDF model, which would again figure out that inverse document frequency, which the model computes. So that TF-IDF model basically, so what it does is it rescales the frequency of words by how often they appear in all the documents, so that the scores of frequent words like the or is, these are also frequent across all the documents. So these get penalized. So this approach of scoring is basically the model term frequency inverse document frequency. So and this is a scoring of the frequency of the word in the current document. So if you say term frequency, it's basically number of times a term T appears in a document divided by the number of times, number of terms, total terms in the document. And inverse document frequency is basically a scoring of how rare that word is across all the documents that you have provided. So that IDF is basically 1 plus log of the total number of documents and divided by the number of documents a term T has appeared in. So there's mathematical formula involved, so you can learn more about it on you just Google it, term frequency inverse document frequency, and you'll get more information on that. So we have to, next step is to convert this text into sentences and word tokens, and we have NLTK library available. So it offers sentence tokenize, so this would convert sentence tokens, and this is our corpus words, this would be word tokens. So this is what we have. Again, you can look at it. So let's look at corpus sentences. So this is, so again, you can see here we have corpus sentences over here, and these are our corpus words. You can see all the words are now tokenized. All right, great. Now the next step is for, let's say, first of all, what will the user do? They'll say, hey, hi, good morning, or hi, anything. So a greeting input. So we can handle those greeting inputs using the same rule-based method. So I have selected these greeting inputs. So this is just a special case for the greeting responses, to generate greeting responses. And I have picked up a few responses again, and based on some random element, I will choose these. So you can see I have created a greet response function, which will basically, what it'll do is greeting message would go inside this greet response function. It would split it, convert all of these into tokens, and now each token is firstly converted into lowercase, and it's checked if it is in the greeting inputs, basically here in this particular tuple. Then it basically returns a random choice of greeting response. So if there's anything in the user query which corresponds to any of these texts, then we generate a response from our greeting responses list. So that's all this function does. Now, very simple. Now, the next step is to pre-process our textual data, which involves punctuation removals and lemmatizing. So again, lemmatization is basically to get to the root of the word. So it's a slight variant of stemming. So the major difference between these is that stemming can often create non-existent words which don't have any meaning, and whereas lemmas are actual words. So your root stem, meaning the word you end up with, is not something that you can just look up in a dictionary, but you can look up a lemma. So for example, lemmatization are that run in a base form of words like running or ran or that word better and good are in the same lemma. So they are basically considered the same. So we'll be doing lemmatizing. Again, you have downloaded the WordNet data corpus from here, from NLTK library. We'll be using that. So this is the WordNet lemmatizer, which we are using from the NLTK STEM module. Again, created a lemmatizer, instantiated the class, created an object. So this lemmatized corpus, this would simply take tokens and then lemmatize all of these tokens one by one and create a list of tokens, lemmatized tokens. Now, this is a dictionary, special dictionary that we have created. So this contains an ordered punctuation, and it'll replace basically with none. So we have created an order of all the punctuations. So if you want to look at it, what this does is basically very simple. So if we run this, so this creates a dictionary for us. So all of these texts, all of these punctuations are now ordered, and these are replaced by their values none. So that's what it does. And we'll remove this. So this is being used here in this get processed text. So this is the function that we'll be using. So let's say the user provides the input. Then the next step is to basically clean it and provide the processed text to the lemmatized corpus. Then it returns it, and it is then passed on to our TF-IDF model, the main model that we're using for intent classification, for the similarity, to find out the similarity. Now here you can see this is basically using the lemmatized corpus, the above function. Now inside of it we have passed tokens. So here we are just simply generating tokens. First we'll translate all the punctuation removal. So this is the punctuation removal part after converting it into lowercase. And what this returns, a set of sentences, and then this is further is tokenized, word tokenized, and these word tokens are then passed on to these lemmatized corpus, and it would return you a list of all the lemmas. Again, very simple step-by-step process. So now the next step is to write the respond function, the entire language model. So this is the function where we actually capture the user input. So this function will accept the user input or the user query, and then what we'll do is we'll have to first initialize our bot response. So the bot response is just an empty string, initialized it. So this bot response is the one where which will actually return from this function. So again, now the next step is to add this user query or the user input to the same corpus sentence that we have created already. So append. So this would get added at the end of our corpus sentences list. So again, we have added the user input. Now the next step is to vectorize this corpus, and for that we are using the TF-IDF vectorizer. Instantiate this class. So this vectorizer accepts a tokenizer. So tokenizer we have already defined, get processed text. So this is, again, it's going to first remove all the punctuations, convert it into lowercase, create the tokens using lemmatize, and then give us the processed text. Basically, the word vectorizer is ready. And then once that is done, we are going to call the fit transform function on this particular object. So word vectorizer, basically we are training this vectorizer using our corpus that we have created. So this will basically capture all the word frequencies and everything, which is what I have explained for how the TF-IDF model works. So we have got the corpus word vectors now. The next thing is to find out the similarity between the user query and the entire corpus that we have. So all the vectors. So as we know, we have appended the user query at the end. So this is corpus word vectors -1. So this is the last element, and the last element is the user message, and then entire corpus. So these are the two vectors between which we need to find out the similarity. So again, call the cosine similarity function, which we have imported above, and we have passed the user message and the entire all the vectors that we have calculated. And then this is our cosine similarities, or the cosine similar vectors. So this call basically computes the lexical distance between our user message, the user input, and each element in our TF-IDF vector. So this is what we have up till now. Now the next step is to, so this would give us a set of scores, and the one which is more similar, the response which is more similar, the vector which is more similar to our user message is going to have a higher cosine similarity scores. So what we are doing is this vector's cosine similarity, this would return a 2D array, 2D list of scores. And what we'll do is we are going to sort this list, and again we are going to capture the second last element, because the last element is the user message itself, which will always have the highest similarity, which the score would be 1 always, but the second last is the one which is like most similar for our user query. So that's why we are capturing after sorting. So this is we have called the argsort method on the cosine similarities using this, again, slicing notation, 0th index. And once we have done that, so the NumPy package basically sorts the array and it returns the indices in order. That's why we have NumPy imported over here. Now the next step is we have to capture the case where, let's say, no response is being calculated. So if we can have that case as well, where user entered something that is not present in our entire corpus. So for that, in that case, what we have done is we have first flattened the cosine similar vectors, then we have sorted them, and then we are capturing the match to vector. So this is different from argsort. This is for NumPy arrays. This will simply give us the score, and we're checking if the score is basically 0. That means that we have not understood, the bot has not understood what the user has entered. So we say, I'm sorry, what is it again, or any message that you want to put here, and then we return this bot response. Otherwise, if everything went well, then we say bot response, which we have calculated, whatever it is, and then plus we'll add this string, the response, basically the response that we have calculated. So this -2, this gives us the index of the most similar response. So the similar, this is the index, and we are going to capture it from the corpus that we have downloaded from the Wikipedia page, from the Cuisine Wikipedia page. Now the next step is to simply start the chatbot. Again, I have started the chat flag as true, and then I am starting off the bot with a message, hello, what do you want to learn about cuisine today? So now, unless this flag is true, we'll keep having chat with our bot. So this is for that. So this is how my bot is going to quit. Or if you can simply check for a quit message. So let's see. So unless we have this true, we are simply going to keep on chatting. So user query, I'm capturing the user query by simply input function. The user will input the query, and then I'm simply converting it into lowercase, and then I'm checking if the user query is not quit, or not thanks, or not bye. So that is also what I'm checking. So if that is the case, I set chat is equal to false. So let's say it's not quit, but the user says thanks or thank you. That means that he's done. So we set chat equals false, and the Cuisine bot says that you are welcome, and the chat ends. Now if in case that's not the case, so if the user query there's nothing is not equal to none, so then we simply do a greet response. So here, if the greet response user query is not equal to none, that is the greet response function has captured something, then we can actually, we apply the user query, and it checks, the greet response function checks if there is hi, hello, so we return that response. Otherwise, we call this respond function, and it calculates and finds out which response is the most similar, and then returns it. And we remove the query from our corpus intents from the end, because we are adding it, so we'll have to remove it as well. So then at the end, we otherwise, basically this is for if the user enters quit, or if he says bye. You can also add one condition for bye as well. So if it enters that, you can simply just end it. So that otherwise, if he adds quit or bye, we say goodbye. So now let's run this. So here we have, so let's say if I say hi, then I get a greet response. If I say, let's say cuisine. So from cuisine, it says the regional cuisines are North American cuisine, Mexican cuisine, Central American cuisine. So let's say I add pizza. So it says, I'm sorry, what is it again? That's because pizza is not mentioned on the cuisine page, and it was not able to find out any similar response. Now let's add beer. So for beer, it has the sentence, which is more similar. So buffalo wings with blue cheese dressing, so well lager of beer. All right, so this is what our bot can actually achieve. Again, this is closed domain. We have like many advanced bots these days, but this is again part to get there. So this is one of the basic ones, and it's being used for closed domain scenarios, like I mentioned, for e-commerce, for airports, for different other scenarios that require a set of predefined responses that can help you improve user experience. So that's what we have for cuisine, basically retrieval-based chatbots and rule-based chatbots. Now the next step would be to capture generative models and create deep learning models and have more advanced learning bots that learn from the data and then generate text to respond to the user query. These include LSTM and RNNs, GRUs, and now we have GPT-3, which has come in. So that also has taken the game to another level. But again, this is beyond the scope of this video, but hopefully we'll get to that.
So I hope you all found that video useful, and if you did, please give this video a thumbs up. Also make sure that you subscribe to the channel. If you have any topics in mind, any questions, feel free to comment down below, and I'll try my best to answer all of you. And with that, we have come to a wrap, and I will see you in the next one.
For new programming updates and videos, subscribe to Coding Ninja's channel.